Man, I hate chemistry. I don't understand the functional groups. I wish I had a fairy godmother.
I can help you understand functional groups.
Really?
Yes.
How?
With this exciting whiteboard and a pen. I can make chemistry fun for you.
Cool.
Just have a seat and have a notebook.
Okay.
See ya in class.
There's antimony, oxygen, aluminum, selenium, nitrogen, oxygen, nitrogen, rhenium, nickel, neodymium, neptunium, germanium, and iron, and beryllium, ruthenium, uranium, europium, zirconium, lutetium, palladium, and
Dr. Katerina Calzides.
Okay, so today we're going to be learning about functional groups because our dear friend was having some trouble. But don't worry. Functional groups are certain arrangements of atoms that have a certain set of reactive properties. Here are some examples of functional groups. This is an alcohol group. An alcohol group consists of an oxygen connected to a hydrogen and then connected to an R group. This is an amine group. It consists of a nitrogen connected to two hydrogens and then also connected to an R group. A third example is an ester. An ester functional group consists of a carbon double bonded to an oxygen connected to an R group and then connected to another oxygen which is connected to an R group. Do you understand?
Yes.
Great. Alright, so these are all examples of basic structures of functional groups, but functional groups are usually present in larger molecules. Remember that it is the specific functional group of a certain molecule that gives it its reactive properties. An R group, you might be confused about, is simply the substituents which are attached to the other atoms. So, for example, this R group could represent a CH3 or a CH2 or any other set of molecules. Here, let me give you an example of how R groups affect functional groups. Here, we have two drawings of amine groups without their R group. The R group could either be a CH3 or it could also be so as you can see, the R groups on different functional groups are what makes them different.
Okay.
Also, there's no limit to how much a molecule branches. The point is to locate functional groups within molecules. So let's look at another functional group that creates molecules called ketones. This is a ketone group. A ketone group consists of an oxygen double bonded to a carbon, and then attached to the carbon there are two R groups. Remember that R groups are just any set of molecules, of atoms, connected to the molecule. So, this is the ketone group, and now I'm going to put up an example of a ketone group within another molecule. And now we're going to try to locate the ketone group. So, remember that a ketone group is an oxygen double bonded to a carbon. So then, if this was the ketone group, these would be the R groups attached to it. So, as you can see, the R groups are different from each other, and like I said before, they're just the substituents attached to the molecule. So, as I was saying, now that we understand the basic structure of functional groups, we can look at their relevance in the real world and how they function when attached to other molecules and how they differ. So first we're going to take a look at two different kinds of alcohols on this board here. And remember that an alcohol is simply an oxygen attached to a hydrogen attached to any R group. And depending on what the R group is what makes different types of alcohols. So the first alcohol we're going to look at is called methyl alcohol. Methyl alcohol contains a CH3 group. So this is methyl alcohol. Next, I'm going to show you ethyl alcohol, which contains a CH2 group and also a CH3 group. Notice that the difference between methyl alcohol and ethyl alcohol is the R group. Ethyl alcohol has a CH3 and a CH2, whereas methyl alcohol only has the CH3 group.
Okay.
Great. So, because of the different R groups, these molecules have different properties. But because they're both alcohols, they also have the same reactive properties. They are both flammable, highly volatile, and clear. But ethanol is drinkable, whereas methanol is highly toxic. So now I'm going to show you an interesting example involving functional groups. So if you look over here to this whiteboard, there's a cocaine compound. So cocaine has anesthetizing effects, but also negatively affects the central nervous system. By removing the methoxycarbonyl group and cleaving the 7-membered ring system, we obtain a new molecule, which is below, called procaine. So, as you can see on procaine, there are different substituents attached. On the ring system, there is an H2N group, and also there are methyl groups attached to the nitrogen. So, procaine is commonly known as Novocaine, and you might use it at the dentist a lot. So in the molecule procaine, there are no damaging effects to the central nervous system. This molecule is further changed, and it makes the molecule lidocaine. So lidocaine, what they did was remove the ester functional group that was present in procaine. So this is the ester functional group, and the ester functional group has a very short half-life, so it wears off really quickly. So by removing that, they created lidocaine, which has a longer half-life, so it doesn't wear off as quickly. So even though something can have detrimental effects, it can be modified to our liking. So isn't that really interesting? So, last but not least, I'm just going to give you a summary so you guys aren't frustrated anymore. So, each functional group has its own set of reactive properties, as we saw in the procaine and lidocaine molecule. By removing a functional group, you can remove certain properties. Functional groups can exist either by themselves or within larger molecules. Other functional groups in a molecule can influence the reactivity of other functional groups, so they work together to create different reactive properties. So I hope that helped you with your studying, and that's all.